Recording is on.
Okay, I didn't know that.
Involved building this thing.
Oh, jeez.
This thing, I don't know if you can see it. The cable and the little connectors and the little board with the tone in it and all that stuff. What a pain to get all that done.
Interesting. Just gonna send a little message to Ken.
Sure.
See if he's. Maybe. Oh, there's Phil.
Hello, Peter.
Hello, Phil. How are you tonight?
Doing fine, thanks.
Hello, everybody.
Peter, did you see my nice sawtooth oscilloscope pattern?
I did. Still don't know why you're dealing with a sawtooth instead of a sine wave, but whatever.
Well, I think the sawtooth makes it more obvious whether there's any distortion.
Okay. It'll be a conversation I'll probably bring up at some point, but I haven't had time to prepare for that conversation yet. Okay, I just sent a message to Ken, but we'll wait for a few more minutes since it's his show tonight.
Just a quick question for Wayne. Did you want the crystal test jig, Wayne?
I don't think I'm going to need it. I was able to figure out what was going on.
Okay, good. If you need it, let me know.
Thank you.
Good evening, everybody.
Oh, hi, Ken. You had me worried there.
I got home at 7:05. Then I had to shovel my dinner down my throat.
Glad you didn't have to shovel your driveway.
What's that?
Glad you didn't have to shovel your driveway.
Yeah, that's coming. Not looking forward to it. So who's on here?
Well, we had 85 degrees today. What are you talking about cold weather?
85 degrees.
Yeah.
85 my butt.
It's going down to 80 tonight. So Eric's got the recording going.
Okay. Cherry, Eric, Dave. Oh, there's Wayne. And Al. Bill. Shall we wait a little bit and see how many other people come in?
I guess you can wait a couple more minutes.
Okay.
It's up to you.
There's our old friend, fellow Jetster.
Yeah, who's the little Dixer? Somebody just sign in?
Should we turn off our videos? Everybody else seems to be doing that.
It's up to you. I know what you look like.
Well, it might save bandwidth, so I'll do it.
It also gives an opportunity to see your chat.
Yikes, who's that?
Anybody else new? Phil, Michael. I don't think Frank's going to be here tonight.
No?
No, he's too busy with his house. I think his house went up on showing started today.
I know Marty won't be in tonight. He's got a conflict.
Okay.
And I'm not sure about Kevin. Send him a message. Hey, you can start whenever you want, I think.
Okay. Okay, we might as well get started here. Any new, latecomers? Too bad.
I'm new. Phil in Kingston, friend of Peter's.
Yeah, I was going to introduce the GARC group. Okay, first of all, I haven't been active in any of the park stuff for probably 3 months now. I lost a brother at the beginning of July, and it just set my world backwards. So I haven't participated in park stuff at all. This is actually the first meeting I've been back to. So I haven't worked on anything at all whatsoever. No DCR, nothing. Frank has been looking at the DCR. He's actually working. He has worked with Kelly to get a prototype board going. I do have it here, and I'll show it a little bit later. But starting today, I'll probably get a little more active. It'll probably take me a while to get up to speed, but I'll get back to things here. As we all know, Frank is going to be moving to Amherstburg, and it's probably going to be sooner than later. As soon as the house is sold, he's gone. They already have a place there. I was over at his place on the weekend. I picked up everything regarding the Homebrew club, all the buildathon equipment stuff, and all the parts and everything for the DCR. And in case anybody's interested, there is 3 SIG-Gen boards with manual. So if anybody's interested in buying one, they're available. If we have a great demand, I suppose we can do another run of boards. But on a might as well get going here. First of all, I assume that Wayne and Phil are part of the golf club. So welcome to our meeting, and I hope you enjoy what we have to talk about. And,
Actually, I'm from the Mark Club. So,
from which one?
I'm from the Mark Club.
Oh, the Mark Club. Oh, okay.
I've been able to get out to a couple of the meetings when they were physical in person.
Oh, okay. Good. Welcome, Wayne. Oh, yeah, I remember you from the buildathons. Yes.
Oh, hi, Ron.
Anyway, so I assume Phil's the only one from the golf club?
No, I'm from the Kingston Club with Peter.
Oh, yes. So we have no, do we have any golf clubbers?
I just saw my friend Ron, who's the fellow jitster,
Oh,
jitster, and he just disappeared again.
okay.
I think he's a rookie at the whole jitsi thing.
Okay. Well, when he gets his camera online, we can he can introduce himself if he'd like.
Ken?
Yep.
Yeah, I just wanted to remind everybody there's a couple of mics that are open, so we're getting a little bit of crosstalk feedback or whatever. So maybe remind everybody if they can mute their mics unless they're going to speak.
Okay, everybody, please mute your mics. if you need to ask a question or you need to speak about anything, in the bottom right-hand corner is a hand. If you press that several times, it'll flash a little dialog box saying so-and-so wants to speak. Do it a few times. Don't do it once because sometimes it doesn't get caught. Okay. Looks like the feedback is gone. Okay, so tonight, we are going to, Michael's going to do a presentation on LT Spice 101. Also, Peter's going to talk about some antenna propagation experiments he's been doing with a vertical. We will talk about the status of the DCR, the direct conversion receiver, and also our buildathons. So if nobody has any questions or comments, we'll let Michael take the table. It's all yours, Michael.
Turn my mic on, and I got to go to my desktop, I guess. That's how we do it. So I got to share first. No, I go to my desktop first, don't I?
Make sure your program's running, Michael. Then go to share.
Yeah, just a sec.
And then go to the application window opens up that you select.
Okay, just a second. The program is running, minimized, but it's running. So okay. So now I should be able to go to share like this and share application window like so. Nothing there. Okay, hang on a minute. I guess I have to start the program like that.
Yeah, for sure you have to run the program first.
Okay, so now I go back to Jitsi and I go share screen, application window. There it is. Okay, you guys see that?
Yep.
Sure.
Okay. So I'm just going to maximize it here. Like so. Okay, you should see a full screen and with the individual pages down the left-hand side. So, okay. So what I'm going to talk about is LT Spice, and this is a sort of a basic thing. There's a couple of versions of LT Spice out there. The original version, the one I started with, was LT Spice 4. It's being replaced by, excuse me, LT Spice 7, which is more up to date. And I understand from some comments that Dave made a while ago that if you've got some specialized libraries, converting from 4 to 7 is problematic. But I haven't had that issue since I'm not using that kind of sophisticated stuff. So I use LT Spice 7. It's available. Just look up LT Spice 7 on the web, and you'll download the program, and it's available for Windows and Mac. And I'm using the Windows version. So what is it? Well, it's a circuit simulation program that allows you to look at all kinds of different models of. You can model pretty well anything, I gather. From simple little circuits to quite complicated ones where you can put sub-circuits in boxes and all that stuff. You can make your own components, your own models of stuff. You can also get models off the web if you're missing something like, I don't know, a transistor model or something, a specialized one. You can go look on the web and download it into the program, and it works just fine. You can do all kinds of different simulations. I'm familiar with more or less with the DC operating point simulation, which you always do to start with, and then the AC time domain oscillation operation, which they call something weird differently, and the frequency response one, and there's a bunch of others too. So these are the ones that I'm familiar with anyway. So yeah, just keep track of the time here. So okay, it's 1:45. Good. Okay, I just want to make sure I know how long it's going to take. So yeah, so what do you use it for? Well, it's very useful for designing and testing a circuit, because you can set it all up in LT Spice and see what it should do before you actually build it let alone solder stuff together, and or even breadboard it, which I typically do first. But you set it up on LT Spice and figure out what's what, test it with your test instruments or whatever, and then you're good to go. And it helps you to understand the way circuits work, and makes it easy to change things. If you're not happy or something is not working the way you want it to work, you can always change it. And once you do that and run it, then you've got something that will actually produce reasonable results, and they compare quite well with what you actually end up building. And lastly, another thing, it allows you to avoid making mistakes, hopefully, because you're making mistakes on the simulation and you don't fry stuff, hopefully. Doesn't stop you from frying stuff, mind you, as I found out. So how do you use it? Well, the first thing you do is you presumably sketch out your circuit on paper first, and then you actually draw it in LT Spice. You put in the component values. We put in the resistors and all that stuff. Then you put values to them. You can add labels that allow you to see in your PC operating point thing, the nodes, give them names instead of just letting them be random numbers. Then you run your simulation, and then you can plot the results and say, okay, what about this? What about that? And you can make changes and just carry on that way. So those are the general steps. So you turn the program. When you start the program, you get an area called a workspace, and a lot of this stuff, or some of this stuff anyway, comes from various LT Spice manuals, if you like, and there's some very good ones. I got a list of them at the end. There's some pretty good ones to look at if you want to know how to use it properly, with some pretty sophisticated stuff. I'll talk about that at the end. But anyway, here's the workspace, and across the top here, there's all the different values. So there's the usual file open stuff here, and across the top there's various different component pieces and so on. So, and this is where you actually draw the circuit in here. And you don't have, it comes up with it starts up with a gray work area with or without grid. You can put a grid in so you can see what you're doing on the grid. Helps to line up parts. You can change the colors. You can change the size of the lines and everything. So it's pretty good. So okay. So this is what the toolbar thing looks like, and this comes straight out of an LT Spice manual. And you can see on all these parts, there's a draw, there's a ground. You have to put one ground in. You must have one ground in your circuit. It won't work otherwise. You must have a ground, so always put that in. You can label the nodes. You can put resistors and capacitors and inductors and diodes and other components. There's a list of components you can get at. You know, various transistors, LEDs, although the LED things doesn't seem to work. Opto-isolators, you know, anything. You can move stuff. Basically, you draw a box around it. You can move it and move components around your workspace. You can drag particular components around if you want. You can rotate stuff. There's a rotate command here. It's shown here a bit differently from what I'm looking at, what I look at. And there's a mirror command. I'll come to this in a minute. And you can place comments with this AA thing. You can write comments on your diagram. And I've got one that's got that in it. And you can, this OP is for placing the Spice directives, which I'll come to in a minute. So that's what you're looking at when you start. In terms of adding components, if you use Control R, when you drag the component down from the toolbar, say an inductor, it comes in a particular orientation. Likewise, a resistor. So Control R, if you do it as you're dragging it down and hit Control R, it'll rotate the component around, which allows you to set it up in the right orientation that you want. Likewise, there's a mirror thing, Control E, which allows you to take, for example, the L2 inductor here and flip it around so it looks the same as L1 if you want to, those kinds of things. The labels down here, there's 10 turns FD3743, I put that in, and that's done with that annotation thing. The component name here, L1 and L2, and when you start, the first resistor is R1, the second one is R2, and so on and so on and so on until you got them all in there. They go in sequential order, so with inductors and capacitors. And when you put the component values in, they show up like this. So like I said, every circuit needs a ground. You must put that in. And one of the things, funny things about LT Spice is there's no transformer model in the program. So what you do is you select a couple of inductors, or 2 or 3 or whatever, and then you use this this Spice OP command K. There's a window. You put it in and you put K at the bottom. K L1, in this case L1, L2, and 1. And this gets the mutual coupling set up. And although this is 100% coupling, so if it was 0.5, it'd be 50% coupling and so on. And you just assume usually it's 100%. So this is the sort of standard way to put in an inductor or a transformer. And when you put it in, you get the polarity dots here. And normally they start with 1 down at the bottom on the one side and up on, or actually I forget now whether it's both on the bottom or one down the bottom, 1 on the top. So then you have to go and you have to flip the thing around. So you flip it and rotate it until you get it this way where the dots are at the top, and then you're a happy camper. And the dots mean current comes in on the left-hand side of R1 towards the inductor and goes out the right-hand side. That's the convention. Anyway, so that's sort of how you do that. So what I've done here, I've got just a simple voltage divider circuit that I just built for demonstration purposes. So what you do first is you click on the new schematic thing on the left-hand side, and then you put the component in. Now what I've done here, I've dragged it in from the resistor lineup at the top, and I dragged it in, called it R1. If you want, you can change the name right away. As it comes, it doesn't have the resistor value. So then you put another one in the second one, R2. And then what you do is you insert a voltage source, and there's different kinds of voltage sources. What I'm going to use is a DC one here. You can use AC ones for a sine wave, or sine and pulse, and a whole bunch of them, square waves and things like that. For a sine wave, you give it the voltage magnitude, the frequency, the phase shift relative to something else, and whatnot. So you put all that in. Then what you do is this is finishing off the rest of the circuit. So I've given the components values. Whoops, let me go back here. Where am I? Back up here, sorry. Oh, back. Wait a second, I gotta go back, sorry. What's going on here? Yeah, okay. So you put the voltage source in, and then you put in the lines, and you do this. There's a line drawing command. So you basically go from the top of the voltage source, you drag your mouse up, and you hang a right angle over. So you come over here, you come to the top of this one, and to get all this stuff, you can just drag right down through. You don't have to do one at a time. You just sort of drag your mouse down through the components, and it draws all the lines kind of nicely. And then you draw the line for the voltage over this output here, and it automatically does the little dot or the square. Likewise down the bottom, it does this one, and then you put your ground in. Then what you do is you label. Well, I like to label stuff. So this is VIN, the input voltage, and this is the output voltage. These two resistors are 100K and 10K, and the voltage is 13.8 volts DC. So you put all that in, and then you're all set to go. So then what you do is what I typically, so this is this kind of thing, you do a DC operating point circuit, and what this tells you is there's a simulation command to do that, and there's a little running man, and you basically set that up for the DC operating point. So it gives you all the voltages in the circuit, voltage and currents and stuff. So it's like it's saying 13.8 volts in the input, the output's 1.2, which is right, of course, because it's a 10-to-1 thing. Divider gives you the currents, 1 milliamp, 1.2 milliamps in each component, and so on. And this is the DC operating point thing. So when you come to do simulations, well, that was the DC simulation, which you indicate by giving the DC operating point selection. There's 6 different types. There's the transient analysis, which really means a frequency sweep. There's a small signal AC, which is time domain analysis, voltage versus time. So you actually get to see the simulation of the voltage versus time. The others I haven't used other than the DC operating point. So when you put the circuit together, it shows this simulation command on the circuit. And if I go back, I think I can show that. Let me go back one. Yeah, you see the OP at the bottom here. That tells you it's because there's nothing after it. It tells you it's the DC operating point. So okay, talk about this. So aside from the DC operating point, you've got a number of other choices that I use anyway. What they call transient analysis actually is a time domain thing. You give it the stop time in milliseconds, let's say 2 milliseconds. You can tell it when. There's a number of other things you can do, and you put that in. It shows up at the bottom left down here. You can see this is what it looks like as a transient analysis thing on the circuit diagram. And on the right hand side, this is the AC analysis here. So you give it whether you want an octave sweep or a decade sweep. You tell it the number of points per octave or per decade. You give it a start frequency and an end frequency, and you use capital M for megs and small m for milli and stuff. And you do all that. It gives you a thing down on the screen on the page that looks like this for the spice directive. So that's sort of how you set it up, and then you can plot results, and you can do a whole bunch of things. You can basically, what you do for a voltage is just left click it, and you get this little voltage probe thing. You touch the wire with, and you click on it, and it gives you this voltage probe. If you click on the body of a component like a resistor, for example, or down here on this pre-drawn circuit, you get the current probe, so you can look at that, either voltage or current or whatever. You can also get the plots to do things like with formulas like impedance voltage divided by current. You can do that. There's a way to do that in the program. So this is the LBS, the PARC Buildathon LBS project. This is the audio amplifier. It was the first thing to build. So just look at this part here in the box. This is just a standard common emitter amplifier. Over here is a push-pull amplifier, audio amplifier. So I was just going to talk about this part here, go into that a bit. So that's what the circuit looks like. You can see the dots against the gray background. Makes it handy to position stuff. You can change the weight of these lines if you like. They come up kind of wimpy, the default thing, so I changed the weight to make them bigger. Some labels here and down here. And here as well. This is kind of a neat trick. You can call something VCC like this. So this is the supply voltage to your circuit. You put a label here, you go over here, and you put another label here, VCC, electrically to the same point. So you don't have to draw a line across here. It keeps things sort of clean. And down here, this is when in the time domain, I'm going to simulate a sine wave. I forget what these. There's the 5 kilohertz frequency. There's no phase angle. There's phase shifts involved. Starts at time 0. I think I forget what that means. But anyway, down here are a couple of the directives for the different things I'm going to do on this circuit. You can annotate it. I haven't done it here, but you could put a title here saying common emitter amplifier, and you can adjust the font and where it goes on the circuit and all that stuff. capacitors here, 10 microfarads and whatnot. So you can set all this stuff up before you start. And here's the grounds, of course, all the grounds here. So yeah, so when you come to do the DC operating point, here it is with the input voltage 13.8, the base voltage 1.22, collector voltage 12.63 or 6 rather, all this stuff, and the collector current 1.19 milliamps, and this is what you get if you calculate it by hand. It's more or less right. Where it starts to get messy is the models, the transistor models and whatnot have capacitances in them, for example, so you don't see things exactly the way an ideal thing would be. So yeah, here is this is a simulation for the 5 kilohertz sine wave input. So you can label your outputs, and on that circuit it was V in for input, V out for output. The scale's different here. So when you look at the voltage gain, it's output voltage divided by input voltage, 33.7, magnitude, which is 30 dB. When you calculate the voltage gain, which in a circuit like this, the voltage gain on this circuit would be the ratio of this collector resistor divided by the internal resistance of the transistor. And you get at that by taking 26 divided by the collector current. This resistor isn't in it AC wise because of the capacitor. Anyhow, so that's an aside. So there's, oh, I didn't get into that, but there's the collector voltage and whatnot. So, and here's the gain calculation, the ratio of the two resistances. And it tells you get 45 by calculation, which is 33 dB. So it's not bad. It's not exactly right. And also a common emitter amplifier, the output is supposed to be 180 degrees out of phase from the input. Well, you can see it's not quite because there's a phase shift here, and that's got to do with the fact that the transistor models, for example, have capacitance in them. So there's time delays going on here that I haven't really got into, but that's why it's not perfect. And in fact, a real circuit wouldn't be perfect either. It'd be close. So this is the frequency response, and let's see, the blue line is the gain, or the voltage, the gain, that's right, versus time in dB down the left-hand side here. The right-hand side, this dotted line is the phase through the circuit. And you can, I'll show this later on, but you can, by clicking on the V out here, you can get it to draw a line, and then you can move this around. So you can look at the gain at a particular frequency across the bottom here. This is gain versus frequency. So you can move that around. You can do it twice and get another line so you can compare, and that's sort of what's going on here. It's got a negative frequency. I don't know why this is not to do with this circuit, I don't think, but, or maybe it is, because there's the gain at this particular frequency, 32 dB. So anyway, you can look at stuff that way. So this is just a capacitor discharge circuit, just for the sake of showing it. It's nothing more than a capacitor and resistor in parallel. You hit it with a voltage at time 0, and the voltage decays, or you start with whatever voltage it was, you remove it after that, and the voltage decays with time. And you can see that looking at the, you can see what's happening here, and you can actually look at different voltages at different times. So what else? Okay, this is, what time is it anyway? I don't know. Yeah, this is my Colpitts oscillator, which I now have time to demonstrate, but here you can, there's the oscillator circuit. This is what I was just talking about. There's the output. So yeah. And when you actually do this on an oscilloscope, having breadboarded this exact circuit, and down here, this is the resistor, inductor, and capacitor, plus the capacitor around it. That is the quartz crystal model. These are called motional parameters, and you can get them by calculation, or you can get them by directly using the PARC SNA. And I've done it both ways, and they come out pretty close. So finally, with this, when you actually run this thing set it up on a breadboard, just on a breadboard, no fancy stuff, no copper ground plane or anything like that. Parts just sort of loose with long leads. This is what you get. Pretty much the same kind of distorted waveform, which is characteristic of Colpitts oscillators, I understand. It's got to do with the fact that transistors are saturated or whatever. Still quite haven't figured that out yet. Anyway, so that's pretty well the presentation. Where you get documentation for this stuff, there's a sort of LT Spice guidelines at the bottom, the 3 ones at the bottom that LT Spice provides. If you look for Simon Bramble on the web, you'll find really, really good presentation on it. And likewise, you can find another one that Laurier University does. So you go LT Spice Laurier and it comes up. And these are very extensive tutorials, web tutorials. There is also, from an Italian person, there's this thing called Spice Simulation using LT Spice, parts 1 and 2. And these are roughly 80-page documents each that go through everything. There's tons of different models. They've got models for things like double balance mixers, and they even get into AC power generation models as well. And you can everything from soup to nuts. And it shows you how to if you go through this, you can figure it. You can see how to plot things, all that kind of stuff. So that's sort of the stuff you can do with LT Spice as the basic things that I know about. So I guess I'm going to stop sharing and ask if there's any questions. Maybe I should do that.
Would you be able to do a quick demo like that? Say, for example, that voltage divider.
Well, what I've got is, yes, I could, but what I was going to do first was show the Colpitts oscillator and what it does when you actually run it.
No, that's fine too. That's fine too.
Any other questions before we go on? Anything else? Yeah. Any other questions?
Go ahead, Peter.
Yeah, I got a couple of comments and a question.
Yeah.
Hopefully I won't stump you on it, Michael, but I'm going to ask. Anyway, I was just going to say I like the idea with the label names. I use them extensively as well.
Yeah.
Much easier when you run a simulation and then you look at it and you want to put a waveform and then you look at all you see is a bunch of node numbers and who can remember what they are.
That's right, exactly.
So, that's a great idea. Transistor models, yeah, you're right with the different betas and characteristics. And I even found when I ran the simulations of a simple amplifier and I changed the transistor to a different one and it got different results. Not big differences, but there was noticeable differences.
Yep.
So a combination of, your actual piece of hardware might be a little bit different in characteristic from transistor to transistor, but if your beta model or if your transistor model's off a little bit, so I mean they can all combine to make it's not quite perfect. Your LBS amp, I found that interesting with your phase shift, not quite 90, or was nowhere near 90, I guess really. And I'm gonna have to look into that a little bit more because I didn't realize that. So there must be something else going on other than the characteristic of the transistor itself. I say that because I did a simple one transistor with no external parts to it really, and the phase shift did come out at 90 or pretty much 90. So that was an interesting result that you got there. A question I have is on the sweep types. Octave, decade, linear, and list are the 4 types that are in there. Do you know by chance as to when would you use octave, when would you use decade, that kind of thing?
Let's see. Octave means that the frequency double. I forget now. Octave means something like the frequency. I don't remember. If I think about it, I'll get it. But basically.
Like I never know if I run a sweep, I'm thinking, should I use octave or should I use a decade or should I use linear? I don't know.
I
Anyway,
don't know. It depends what you want to look at. I guess the display across the time display across the bottom is different depending on what you use.
mhm.
It doubles, the octave doubles every something.
Okay.
I'd have to look that up.
No worries. I could probably do the same thing too if I'd ever remember. Okay, that's it for me for my questions. Thank you.
Okay, so let me see if I can get the Colpitts oscillator thing to work here. I guess I turn it on first and then I share. That's what you said, right?
Yeah.
So I'll turn it on. There it is. I got it there. Now I can go back and share. Where is it? Okay, share.
Dave has a comment, Ken.
Sorry, what?
I think Dave has a comment.
Okay. Go ahead.
Go ahead, Dave.
I'm not hearing.
Hey, Dave, there's something wrong with the audio. You wanna leave and come back in?
Okay, you guys can see this?
Yeah. Yes, sir.
Okay, this is the Colpitts oscillator, the same circuit I showed before. And here's the crystal, quartz crystal. Here's the biasing resistors. This is a transistor amplifier, basically. If you take the capacitors away, these ones, and this thing away, then you've got a standard common collector amplifier, which has the characteristic that the voltage gain is a bit less than 1 because you've got the voltage drop across the emitter base here. And what's added here is this plus this circuit here. These two capacitors are in parallel with this to ground. That collectively forms a tuned circuit that oscillates at a particular frequency, and you can calculate that. So anyway, that's what this is. So now I'll show you. I'll actually draw that voltage divider circuit in a minute. But basically, what you do is you go across the top here. Here's all your resistors and stuff. For example, I can drag a coil in. I guess I can't. I don't know why that won't work. Uh-oh. Anyway, in here. Oops. Sorry, that wasn't. Something's not right here. Let me go back here. Oh, I know why. In here, you go down here to select your simulations. So here they are here. I don't like this stuff dropping into it. I haven't seen that before. It's got something to do with Zoom or Jitsi. But anyway, you got the transient analysis, which is the time domain. You've got the frequency analysis here, which allows you to put the sweep in, octave or decade or whatever, and the number of points. This is wrong because it's not. We're not talking about a sweep simulation here. A frequency thing. Here's the DC operating points, and if you click on this, it gives you, hopefully, where is it? Oh, then you go here. The running man starts the simulation. So what you got here is the DC operating point. So you can see the base voltage VB is 7.7. The collector voltage is 13.8, and so on. You can see all the currents and everything else. You can tell the DC emitter current coming down here is through our E, so that is where is it? 1.03 milliamps, which is what it's designed for. Anyway, so you can look at that. Then you change back. You edit your simulation command, and you run this one, which is the transient simulation time domain, and you start it. And down the bottom left, where it says Run LT Spice, you see what's going on. And it's simulating down here. So I hold my mouse over here on the diagram to the voltage thing. This is what I get. And down the bottom, you can see, bottom left, you can see it's running through the simulator 33, 34, 36%. And I find this quite dramatic. Dave told me about this. It takes time for the simulation to go. It's not instantaneous. So what we're seeing is the voltage developing over time, over 4 milliseconds or whatever it happens to be. And eventually it stops when it's all done. And then you can look at the results. 60% done. Just got to sit tight here. It's just about finished. What's going on here? Oh, there it goes. Okay. I suspect the computer's sharing resources with Jitsi, and that's why it's delaying things.
Okay, Wayne wants to say something. Go ahead.
Okay, Wayne, go ahead.
So what we're looking at then is the oscillation beginning, right?
That's right. You're looking at the output, the AC output on the right-hand side of the capacitor at the bottom, C3, versus time. And
Okay.
it's taken its time to do this. I'm not sure why.
That's cool.
Why is it not finishing? I gotta wait for a second till it finishes. What I was going to do is grab the frequency and show how to do that. I'm not sure why it's taking so long here. I don't know if I can
Michael,
grab
your steps are too small.
Beg pardon?
Your steps are too small.
Oh, it could be.
You're doing much too, like if you look in terms of the time span you're doing it, and in versus the steps you're doing it.
Okay, well let's take another look at it then. Simulate. So what do I do here in the? I haven't got a time step here, Dave. I've just got.
So then stop time is 4 milliseconds. Say, like for example, make that start at say 3 milliseconds.
What start this to save the data at 3?
Yeah, start saving 3 milliseconds.
All right, let's try that. Like
And then
so. Anything else?
Yeah, try that. Then if that doesn't work, do a change your time step.
Yeah. Okay.
You could see at the bottom, see the percentage at the bottom.
Yeah.
57, 60, 70.
Yeah.
You can
Okay.
see it's
Here it
racing
goes.
along now.
So hopefully this will be faster. If it's not, I'm not going to belabor the point. I'm just going to.
Yeah, go back to the bottom window and see how it's.
Down
Just
here?
put the mouse in the bottom window.
Not
and
seeing
see how
anything
it's
down.
progressing.
It's not showing anything down there.
You didn't pick your voltage tool.
Oh, of course I didn't. That's exactly right. There you go. Here it is. Okay, there we go.
Yeah, I don't know why it's.
I don't know, but anyhow,
Yeah.
yeah. When you get it done, you can basically click on the voltage up here, and you get those markers, and you can get 2 markers. So I'm not gonna bother with this. I think it's interacting with Jitsi for some reason. I
Set
think.
it for 1 millisecond of max time.
All right, let's try that. Okay, simulate. Let's try that. So we'll
Restart, Michael.
Wait,
Restart. Restart LT Spice.
Okay, let's do that. Yes.
When you start to talk about the signals up in the megahertz range, maybe you might even want to go down to microseconds for a sweep time, depending.
Well, it works. Normally it works. So I'm not sure.
Yeah, milliseconds for like megahertz. It's huge. So it's got to do a ton of calculations. Typically, when I do a simulation at megahertz, Peter's right. I use microseconds.
Okay, let's restart it. Yeah, where is it? Okay.
Yeah, I maybe even cut it down. Don't go to 50 microseconds or something like that, I think, Michael.
All right, let's try that.
But it may start up. It may need a delay for it to start up, right?
Well, I don't want to. If we got the time, fine. If you want me to go on, we don't have to look at this. It's up to you guys. I don't want to waste your time. What do you want to try here?
Just a couple of comments. You were talking about nodes. Michael, if you go up to netlist, under view, it's got something called netlist. And
Yeah,
if
I know
you
about that. Yeah.
view your netlist, it'll show you all your nodes.
This one here. Yeah. Yep.
You can see all your nodes because
Yep.
Peter was saying about labeling nodes. Well, here you could see what the mapping is for your nodes. It's a little bit easier.
Okay. Anyway, let's go back and Peter asked, well, can we do it? Let's just do a quick file new. So if I want to do a voltage divider, what I do is I pick a resistor and I put it in like this, and I pick another resistor and I put it in like that. Then what
You're
I
not
do-
sharing your screen.
Hey, oh, sorry, yeah. Sorry. Wait a second. Where is it? Down here. Oh, come on. What's going on here? I got two Jitsies going or something.
And he's gone. Hey, Klaus, I like your background.
Unmute Mike.
You're muted, Klaus.
Sorry, it's my psychedelic mood lighting. It's easy on the guys when I'm working on the computer. Kind of nice.
Boy,
Looks nice.
It's coming along really nice, Klaus. I bet you Dave is getting really itchy now when he sees new shacks being built and his is still in a box.
Well, I finally got an antenna today, so I'm going to start putting that up. And with you guys here being the experts for putting up a tower, we've got one at the church, and basically what it is, it's I think it's about 30 feet tall. They've got a metal plate on the roof, and they've got an anchor to the side of the roof, and that's all they're doing. And the thing's got a dish on it. It's never come down.
So, okay, let me just start over here. Can you see it?
Yeah, we can.
Okay, so basically you drag a resistor down like this. You click on the resistor, drag it down. You drag another one below it. You hit escape. Then you drag. And then you get a voltage source in here. So you go over here. Where is it? Voltage source. I don't see it.
Extreme right, second from the
Yeah,
bottom.
that's what I thought. There it is, voltage. That's right. So you put this in here like so, and then what you do is you basically use the line function and just go like this over here. Whoops, up to, let's say, here, and then you go from here over to here, and you just go down like that right through, and then you go over this way and back up like that, and then you put your ground in like so, and then you put a line in here like this, and give this a name, the out, like that. And up here, you give this one a name, the in, like that. And then you give your component values. Let's make it easy. We'll go 10K and 10K down here, so I don't have to think about calculating numbers. I get back up, and now we'll call this, I don't know, 20 volts, let's say. So there's your circuit, and now what you do is you go and you edit the command, and you tell it DC operating point. Oops, yeah. And then you go simulate. No, whoops. Something's not right here.
It didn't take your DC operating point command.
You named the voltage source instead of setting its voltage.
Wait a minute, what's happening here?
Check your voltage source. You didn't set the voltage correctly on that. You changed the name instead of the value.
Yeah, that's right.
Right.
The label.
Okay, let me just delete it and put it back in then. Oh, 10 volts.
There you go.
10. Okay. Let's change that to 10 volts. Let's try it again. So we go simulate. There it goes. So now it's telling you the input voltage is 10. The output voltage, because it's half, they're the equal values of resistors, it's 5. And it's telling you the current is 5 milliamps here. Yeah, no, 0.5 milliamps. Anyway, so that's a quick and dirty how to do it kind of thing. Questions? That's good. I'm off the hook.
Yeah.
Okay, so yeah.
I saw Dave asking.
Oh, what, Dave?
When you select the component, don't you right click on the component?
To get the value? To put the
when
value in, you mean?
Yeah, the value, because the way
yeah.
you're doing it, it's like as if you're changing the label. Right click on.
Oh, this is wrong. I did the voltage source wrong. That's right. That's
No,
right.
no, no. On the resistor, go
Here?
and right click on the resistor.
Yep, there it is, 10K.
No, I'm running a different version of LT Spice. If I right click, I get a window coming up, and it's asking me like it's manufacturer part number, resistor tolerance, power level.
Gee, I don't know.
Are you right clicking or left clicking?
I'm right clicking on my mouse, and I'm getting the name R1 here.
No,
because okay. If
right click on the resistor itself.
If I right click on the label, I get the name R1. If I right click on the resistor, I get to put the value in. It doesn't do this way. The way I do it, I don't see manufacturer's tolerance and all that stuff. I just don't
click on the resistor. Click on the squiggly line.
Say again?
Click on the squiggly line.
Ah, okay, in here.
Yeah.
Yes, that's right.
There you go.
Yeah, so you can put in select resistor. I don't know what that'll give you, a whole bunch of stuff, right? And when you're doing a transistor, for example, let's just drag a transistor in here. We don't have to actually we don't have to connect it to anything, but let's take an NPN transistor, for example, this guy. So you put it here, and now you can, when you right click on it or left click on it, you get the choice. So I can pick a new transistor here. So I can pick a 293904, which is what I use all the time, like so, and whatnot. So you can pick any number of different transistors. You can get a list of them. Basically, you got all these transistors here, and the spice model is over here on the right hand side. So if you're really brave, you can take your 2N3904 and change the component values. Yeah. So the question of why that phase shift is not exactly 180 degrees, which it should be for a common emitter amplifier, I'm not sure. I think it's got to do with the internal capacitances and whatnot, but and depends on, you'd see, depending on the frequency you use, you'd see different degrees of phase shift. I don't know. Anyway, so that's all I got. Any more questions?
I think Klaus had his hand up.
Go ahead.
Yeah, this is not so much about the circuit, but it's about LT Spice. I was making a very small little breadboard circuit with basically had an IC with a couple of alternating LEDs, and it's a very basic little thing. And I was going to put it on LT Spice, and I was looking for doing a drawing just like you did here, a very basic drawing. And I wanted to put the component in there, and I forget what the number was of the integrated circuit, but it was not in the component list. So I basically scrapped that. So how do you import components that aren't on the list?
You mean individual components or IC?
Yeah.
Like a resistor or a capacitor or something?
Well, no, this would be I think it was a 5055 IC or something that they use to make these alternating LEDs flash.
Okay, so it's not in this list here then.
It's not in the component list, no. No,
well, yeah. Well, I guess what I would do is go to the web, look, put 5055 LT Spice model, and someone will have done it, and you can download it and import it into LT Spice. I've done that once. I don't remember exactly how to do it, but basically that's what you do. Go find it on Google it. Google it as LT Spice model for whatever, and then save it, I guess, and put it in a folder, and then import it into your drawing. That's into your simulation. That's what I do. Try it.
Okay, we'll try that. Thank you.
I know it works. I've done. By the way, Dave, are you still there? Dave, still there?
Yep.
Okay. The LED model here. How do you tell it what LED it is? Because when I tried to do this, I just saw diode or something.
Right click and pick a new diode.
Okay. And you have to know the model number for the LED,
Right. That's right.
which I don't know.
And you know what? It doesn't matter. An LED is a diode.
Well, of course, yeah. So you just pick
I just pick a diode which close matches it.
There you go. So now you just connect it in like this.
Yeah, but I was going to say about the library costs is that if you go, I believe, because there's a really good library out there. It's got the NE602. It's got.
Thank you.
Okay.
Recording is on.
I think Hassan had his hand up.
Yeah.
Hassan?
Yeah, I just wanted to say, if you want to add models to Spice, what you can do is just download the text file and use a .include statement. There's a command somewhere to add Spice directive, and you just do that. In fact, the easiest way to look at these circuits is just save them as a text file, and everything you see on screen is basically just a big text file, which you can run through the Spice command on the command line. And there's like, if you want to add a circuit, you can, like a model, you just cut and paste the .model directive into your source file. So it's harder.
Yeah,
long term, it might be easier to conceptually see. You don't have to deal with the GUI at that point.
yeah, now that I think about it, I've done some of that. But yeah, it's a learning process figuring this stuff out, and but it's really good because you get to do stuff without destroying things.
Okay, I think. Oh, sorry. Go ahead.
No, it's okay. That's fine. Yeah.
Dave had his hand up.
Yeah, in terms, a couple comments, Al. The best way to learn Spice is out of necessity, I find. The way I learned Spice was because I wanted, if you're just trying to use Spice just for the sake of learning Spice, good luck. For me, like for example, a really good example is using your digital interface and modeling that, and that's the way you learn Spice. And that's the way I kind of learned Spice, was out of necessity. I've got a circuit, I didn't know how it worked, and I ran it, and I said, okay, what does AC analysis give me? And then I'd run AC analysis, and I would figure it out, and that's the best way to learn. The other comment about Hassan about doing an include, it's not as easy as that, because you got to have a model file as well. So you have to have two files. You have the include file, and you have to have a model, which that include file is going to reference certain labels that has to be in your model. Because if you look at your a model like of a transistor, it's got collector, emitter, and base. So your include file will have to have that defined, what it does. So it's a little bit more complex than that. I found it was I ended up doing that, what Hassan's saying, but the easiest way of doing it is to get someone else's work and just pull it in as a library and make it work. That was the far easier way of doing it.
There's all kinds of tricks to this stuff too, as Dave has shown, like things like, well, how do you get when you're plotting stuff, how do you plot things? And you can do things like if you want to find the power through a circuit, what you do is you hit your Alt key, you hold your mouse over the component and hit the Alt key, and it gives you the power dissipation of, for example, a transistor, milliwatts. Well, who knew, right? There must be something written down somewhere that says to do that, but I haven't found it. I haven't bothered to look, actually. But things like rotating the components, Control R does it, and there's the other one, Control E for mirroring stuff. There's a table that I found that I think I've got bookmarked here that shows those kinds of control keys that are useful to know, But it's just a matter of learning and doing stuff, like Dave says.
Okay,
and the beauty of it, you can't hurt anything, right?
Yeah. Go ahead, Phil.
Yeah, I've got a question about digital circuits. In the component library up at the top there, where you pick up your voltage source or whatever you want, you can pick up digital circuits too. And in there, you've got like AND gates and OR gates or flip-flops. But they don't seem to be very logical. I can't seem to do anything with them. And I wonder if anybody's got experience with, you know, configuring an AND gate, for example.
Not me.
Yeah, I use them for doing like type of a Schmidt trigger, where I have an AC voltage coming up, and I want it to trigger something. So once it hits the threshold for a high voltage on an OR gate or an AND gate, I can fire the output. So I've done that like as a Schmidt trigger, because that's exactly what a Schmidt trigger does. It triggers. So if you've got a lot of noise, it doesn't trigger. It's got to get beyond a threshold, and then it triggers.
My problem seems to be that right at the start of trying to configure the AND gate itself, it comes up, looks like a 5-input AND gate, and there doesn't seem to be any way to configure it. You right-click on it, and it doesn't give you those kind of options. Let me just share my screen for a second and show you what I mean.
Yeah, go ahead.
Okay, can you see that screen then?
Yep.
Yes, sir.
Okay, that's an AND gate that I added there. I'll add another one. You go up to the top here where you got components, click on that, and you go down to, well, I'm already in digital, but you could click on an OR gate, for example. So it adds an OR gate. So I put it there. But now when I right click on it to configure it, it doesn't give me any options that are very useful there. Like the OR gate looks like it's got 5 inputs and a bunch of outputs or some sort, but
no, that's a third party. That's not a inherent LT Spice model. It's not a linear model. So yeah, you have to go in. If you bring that up again, that little table, yeah, you have to go in there and you have to put in certain values in there. I don't know exactly. I've never used this, but you have to know what you're doing. That's very, very complex.
Like, could I convert it to a 2-input instead of a 5-input or whatever it is?
Yeah, okay, keep talking. I'll find you a circuit that I did with digital logic.
Dave,
Okay, well, I'll stop sharing mine then.
Dave, when you're talking about, can you hear me, Dave?
Yes.
When you're talking about linear, you mean linear technologies. You mean an LT Spice model produced by LT Spice,
right? Yes, a linear technology model, part number. Yeah, that's correct.
And while we're on a pause, I'd like to say hi, Simon. Go ahead, Hassan.
Yeah, it looks to me like those are ideal AND and OR gates. So basically, they have zero input capacitance, and the threshold voltage is exactly half the supply voltage. So what you'd use them for is, if you have a perfect square wave coming in, you'll get a perfect square wave like a perfect pulse coming in. You'll get a perfect pulse coming on the outside with zero delay through the gate. But what you want to do is you want to have like a slowly rising pulse, like a soft pulse, and then you look at the output. It'll probably be sharp, but there'll be some delay between the output and the input, and that's what you would use it to model.
Yeah, but my issue would be if you've got an AND gate with 5 inputs and you only want to use 2, it won't work properly.
No, it won't. So what you can do is you can tie the unused inputs to 1 to VCC, tie them high, and then your AND gate should be fine.
Okay, so you have to accept that there are 5 inputs and you just got to short them out or whatever.
Yeah, tie them high for ANDs, and for ORs you tie them low.
Yeah. All right. Thank you.
Yeah, no problem.
Anybody else got questions or comments? How's it going, Dave?
Yeah, I gotta find it. It's where did I put it? Because I did a rocket beacon using buffer amps, digital buffer amps, and I gotta find it where I put it.
Yeah, it would be really great to see an example of a digital circuit using, let's say, the 7400 series TTLs or something like that. And I know that you look on, if you search on the internet, there's a whole bunch of indications that there are libraries out there for the 7400 series and the more modern CD 4000 series. But you have to somehow bring in those libraries.
You might take a look at that, at the latter two, or the last one, the one that I referred to as done by the Italian guy, the part 1 and part 2 things. There may well be something in there on digital. I haven't paid attention to it because I haven't needed to, but take a look at that. But I will send that thing around right after the meeting.
Okay, thank you very much.
Go ahead, Dwayne.
If you go to YouTube, there's a bunch of little tutorials and things like that on LT Spice, and there's several of them on using digital circuits, simulating digital circuits. There's also a couple of free books on Amazon Unlimited that are on LT Spice that you can download for free.
Okay.
That's good to know. I didn't know that.
Okay. Well, we got to, what time is it? 8:50. Maybe while Dave's still looking for a circuit, Peter and I were talking over the weekend about the buildathons. Looks like we're going to be self-isolating or isolating for a very long time. The American border is not expected to open till minimum December. I think it's going to go way into next year. Buildathons. Our choices are we do everybody jitsies in to a Saturday session and we all put our circuits together, or everybody puts their circuits together and then we could have again another Saturday session. And if people have problems or questions, then we could work it that way. What do you think, Peter?
Yeah, yeah, you're right. We had two ideas. One, actually, the second one you brought up was the thinking was maybe we would start off with it. First off, everybody would have the kit, and then we would have a Jitsi session as an introductory, just a short, just to get things started going, and then maybe take a week or so, whatever we decide, 2 weeks, I don't know, to build, and then have another Jitsi session at the end to go over any last minute touches. And of course, in between groups IO or any ad hoc Jitsi sessions for anybody that's having troubles can be accomplished as well. So that's the one way. That's the way I think would work. Or like you said, pick a Saturday that we'd have the normal build-a-thon day on and have Jitsi running, and then just everybody build at home and just have the sessions running basically for the day while we build. I mean, that's another option too. So, you know, there's the two ideas. What does everybody else think?
If you want to comment, just go right ahead.
Well, I kind of like the first option where there's an introduction and then we work on the kit, and then maybe there are scheduled checkpoints or maybe ad hoc things set up through the groups.io. But, you know, I work kind of slowly, so it would be nice for me to do a bit of work before the next discussion, I guess.
Yeah, we could do it that way. I think we could try it that way. If there's problems arising, we can try the all-day Saturday way, and then we could all decide which way we prefer to have it. The DCR, I don't know when it's going to be ready. Kelly had made Frank a prototype board, or actually it's the third in a series of 3. I don't know if you could see this. It's the last version Kelly had milled. On the bottom are the 3 controls, one for volume, one for coarse tune, one for fine tune. and the audio connector on the side for plugging the speaker or headphones. At the top, we have an SMA to hook in your SIGGEN, or the big BNC for an antenna, and then the connector for power. Now, according to Frank, this works perfectly. The only thing he had a problem with is the bandpass filter was a little on the wide side. Now, we had spoke about using a digital chip of some kind to produce our oscillator for our local oscillator. There's nothing out there. So with the current version, there's two ways to do it. We can have an analog, we'll have an analog plug-in oscillator, or you can use a SIGGEN. The advantage to the SIGGEN is it gives you a frequency readout, whereas the analog VFO doesn't. And we had talked in the past of making some kind of pick frequency counter, a real cheap one that you would plug in. But my question earlier in the evening was if everybody had a SIGGEN, that would be the way to go. If people need a SIGGEN, we have 3 boards and 3 manuals. And if there's enough people that need it, then maybe we can just do another run. But as it stands, I've built the same circuit, Manhattan style. I've built it with the analog VFO, and I've built it for the SIGGEN, and both work quite well. I'll have to take a look at the bandpass filter. This one's set up for 40 right now. We're going to be having options for a 20 BFO or VFO and a bandpass filter. And we had also talked about having extra boards. You can say build your own for say 10 meters. It'd be totally up to you. Because of this COVID thing, getting boards done is going to take a lot longer, and it's going to also take a lot longer to source parts. Frank had already purchased, I'm guessing, about 50% of the parts for, I think, 25 builds. But this still has to be worked on. This prototype board is going to go to version 4, because if you look at the 3 controls at the bottom, there's not enough spacing on them for knobs. So I would have to talk to Kelly about moving that speaker input jack onto the back with the other connectors. Okay, go ahead.
Sorry, I've got to get off mute here. Looks great. Looking forward to it. Just a thought, I'll just throw it out on the table. Doing the DC receiver was kind of an effort to get back to basic for new people to home build and whatnot. And with the COVID and shutdown, and suggesting we do this on a Jitsi build, are we gonna miss the target? Like, how many people new to home building are going to be willing to try to build this on their own with only a Jitsi interface? I'm just wondering, maybe we should perhaps park this project until the COVID is over, and maybe consider something for people with more experience, probably the core people in the group, and do something like that. Any comments?
What do you think, Peter?
Well, first off, the DC board is a pretty simple board, and it's all through-hole components. So that's an easy first project. Looking at the success that Chat with the Designers group has had with the Phaser project, and these guys are all, a lot of them are first-time builders, and of course they're all remote, and they're using their group's IO as as a support mechanism. And of course, the designers of that project are already available on there, and they seem to be very successful. So, and that's a far more complicated board than what our DCR is. So well, easily for me to say, I suppose. I don't see an issue with it. Of course, there always could be, but I think if there ever was going to be a project to try for your first time out, our DCR project is a good candidate for that, I think.
Well, the only problem I can see is soldering skills. Go ahead, Michael. You're muted, Mike.
I had a comment not directly related to this, but in terms of how you're going to put this together, I would have thought as far as I'm concerned, the DCR is relatively simple. So, you know, but you remember with the LBS, you sort of had tutorials. We built, I think, the audio amp first, and somebody talked about it, and then I think you talked about the filters, bandpass filter or something, little tutorial about, you know, how it works and stuff. Maybe part of whatever we do with the DCR would be worth doing that to have either one of the group research and explain part of it, or have somebody talk about each stage and how they fit together. I don't know, just an idea.
Yeah, that's possible. The only problem is I don't think there's enough on the board for several people to break it down and talk about it, because basically it's two ICs.
Fair enough. Yeah, fair enough.
A mixer and an amplifier. If need be, I could do a presentation of how it works. It's very simple. And I think I could explain it well enough for a beginner to get a handle on what's going on.
Fair enough. Sure. Yeah.
Any other comments or questions regarding this?
Yeah, one here from Al. What about test equipment for doing this build? Simon usually brings a whole pile of test gear. Will all the participants be able to assemble it with basic tools?
I think so. Now, it depends. Your definition of basic tools may be different from Peter's, and it might be different from mine. I have a frequency counter, homemade. I know Dave has. Peter does. Al, do you have a frequency counter?
Yes. Yeah,
Okay.
I do.
So there's a basic tool. If for some reason the DCR doesn't work, do people have a use of an oscilloscope to check to see if there's a signal coming out of the chip, the 602? So that might be a tough one. That might be a tough one to do.
That's if somebody has troubles and it doesn't work.
Go ahead, Dave.
Yeah, I would first, before you look at doing this, I would first ask how many people would participate in this. Because if it's going to be a handful of people, just go to a room. If it's going to be 3 or 4 people, go to a room and separate yourself by like 10 feet. You know, everything will be fine, right? Now, if it's going to be a larger group, why don't we look at doing something outdoors, or why don't we look at doing something in an underground garage, or, you know, yeah, like something under a shelter, but outdoors, where you still got everyone together and you just physically distance yourself.
Yeah. Yep, I agree. I think we have many binds here that we could come up with a solution if we need to get together in a small crowd. I don't think troubleshooting will be a problem. It might take a little longer to fix somebody's DCR that's not working because we're constrained on space, but I think we can work it out. It would have to be planned. It'd have to be well planned out.
I also found the LT Spice model. So whenever you guys are done, let me know. I can show it.
I'm done talking about the DCR for now. like I said, I'm going to be getting back into this stuff very soon. I want to look at that bandpass filter that Frank was talking about, and also talk to Kelly about getting another board milled when he has time to get those that speaker connector on the back and get it away from the front. Somebody had their hand up. Go ahead, Pete.
I know you have a list of people who have already put their names forward to build this project. Maybe it might be not a bad idea to revise that, or like get all those names there, and then specifically ask them, okay, what would you like to see? How do you want to conduct it? Are you comfortable building on your own? That, et cetera, that kind of thing.
Yeah, maybe what I'll do this weekend is I'll put an email together. I'll put the names of the people that were on the original list and pose the question. And then that way you can return a response. You return it to me, not to the group. And I can compile all the information and maybe post up on the group what the results are. Anybody else? Okay, we're just starting to run. Oh, go ahead, Cherry.
Perhaps we can put a Google form. It will be easier to get the responses, right? So.
Yeah, absolutely. We will come up with a solution when it comes to needing something.
Just a general comment here, if I can.
Go ahead.
I think as a club, we should not worry about this COVID thing in that sense, because it's going to be around for a long time. And if we could keep putting everything off because of COVID, the club's going to take a hit. So I think we should go with the assumption that we're going to do this. We'll find a way to do it safely and get people involved, but we should be doing this.
Yeah, absolutely. Field day. I know of clubs that actually set up multiple stations at the same site, but they were away from each other, and they had all their stations set up in a 150-foot radius circle, but people were separated, and they were still able to operate field day.
Well, we discussed that at the executive meeting, and it was said, well, the city of Brampton isn't letting us do this. Well, why in God's name do we need the city of Brampton? We've got church parking lots, we've got everything else. Screw the city of Brampton. We don't need their facilities.
No.
We could have had field day.
Yeah, exactly. Someone else had put up their hand.
Yeah, I did.
Yeah, go ahead.
So I just got a new SDR radio, a Blade RF, and I'm trying to figure out how to use it now. So there's a repeater right across the street from where the library is, Fletcher's Creek. And I was wondering if someone could tell me how I can actually ping it, and maybe, because it's only 1 kilometer from my house, and my radio's got like 6 dBm or 8 dBm power output. So I might just barely be able to reach it. But I've never actually used a repeater before. So does anybody know what frequency it's on? Or?
That's the PARC repeater, and it needs a tone input to activate it.
Can someone send me details?
103.5 hertz.
103 megahertz?
No, it's a subaudible tone. When you transmit, when you key your repeater up, when you key your handheld up, it transmits to the repeater. It turns the repeater on, but all the repeaters around here are set up with subaudible tones, and it's 103.5 hertz in the GTA, and you have to provide that with the audio input, your audio output out of your handheld, so that the repeater will turn on. It needs the PL tone to turn on.
Okay, yeah, it's a PL tone. Okay, and is it above or below the carrier?
Well, it's the carrier. Let's see, it's a 103.5 hertz tone that rides on the carrier. So it's your voice is whatever frequencies it is, but this is underneath the voice. It's way down in terms of level 2.
Oh, I see. Okay. So I just transmit AM and embed this 103.5 hertz tone, and then it'll. And what's the offset for the repeater? Is it 5 megahertz?
Well, on a VHF repeater, the offset will be 6. The frequency of the PL one, I forget what it is 146.880, and the offset is 600 kilohertz below that. So your radio would transmit at 146.280, and the repeater comes back to you at 146.880. So on your input signal, you said you put the tone on that 146.880, 280 rather.
Is this information recorded anywhere, or could you email it to me on the group?
I think it's on the website.
And it's
Okay.
also FM, Hassan. It's not AM. You know
That's
that.
right. That's right. It's FM, not AM. So you have to transmit FM to the repeater.
Okay. So, all right, perfect. So I'll see if I might be able to reach it with just a omni. It's about 1 kilometer from my house, so 8 dBm is pretty low power. I don't know if it'll actually get there.
Go ahead, Pete.
I'm not sure that's our repeater. Isn't our repeater at the Christian Hall and Homes? The one that's just down the street from Fletcher, is that maybe the Portuguese repeater?
I thought ours were on the apartments across from Fletcher's.
Is it across from? It's been so long since I've been there, I can't remember. Okay.
Send an email to Paul Allen at VA3PB. He'll tell you. Paul knows this stuff.
Yeah.
Yeah, it's on Grace Tower at the Holland Christian Homes.
Or across the street, right?
Yeah, at Kennedy. Sorry, at what's the name of that street there? McLaughlin and Steeles is where it is, right on the corner there almost. Right across from Sheridan College.
Yeah. Okay. Someone else had their hand up. Dave?
Yeah, Hassan, one of the easiest way you could do you have a handy talkie? Set it to receive with a tone. Program a tone in the handy talkie to receive a 103 hertz or whatever hertz tone, and then transmit and put it right beside your transmitter. And if that works, drive over to the repeater and try it.
Okay, I have to buy a handy talkie first. Thanks.
They're cheap. Buy an illegal one. You can get them for $30.
Yeah, I'll
get a bay phone.
Eric's got three or four of them. Borrow one from him.
Yeah, I might just have to do that. But I want to test the SDR out, so because all I can do is listen to CBC radio and some aircraft going overhead, but it's pretty good. But I haven't transmitted yet, so I want to try that out.
Does it demodulate FM?
Yep, I just use any of the SDR programs out there, and it demodulates it pretty well. In fact, I built one with GNU radio. It took me 2 or 3 hours because I had my RTL SDR dongle plugged in with no antenna, or sorry, the antenna was on the wrong SDR, so it took me 2 hours to figure out that. Once I got that done, it was like 20 minutes to set up an FM demodulator in GNU radio. It was pretty slick.
Okay, go ahead, Phil.
Yeah, while you guys were talking there, I tried out that AND gate, 5-input AND gate, as was suggested, and it seems to work. And I'll just show you what I did. And I don't know whether it's too clever or not, but it seems to work. So I'll just share my screen and show you that. So there's the diagram. It's 5-input AND gate, and I've tied 4 of them to the voltage, so that they're on. So the 5th one is not on. There's no connection to it. And if it's on, there should be some current flowing through the R3, which is the resistor on the right-hand side. So if I run that, I get this. Shows the voltage, and it shows no current going through R3. In fact, there's no current going through any of the resistors because you're just tying them to the voltage and pulling up the gate, the input to the gate. So there's no current running there. So there's no current running anywhere at the moment. So I stop that and then connect those, connect the other gate. So I'll just connect it with a line here. Like so. Whoops. Didn't click on it. Try that again. Okay, so I've got the other gate connected now, so all the gates should be pulled up to the supply voltage, and something should happen in R3 on the right-hand side. Whoops, gotta get rid of that. So I'll run it again and see what happens. So now you see R3 has a current going through it. It didn't have a current going through it before.
Oh, cool.
So I'm sure the values aren't right. The voltages aren't really right for that particular AND gate, but the concept works. So whoever suggested tying those extra gates to plus or minus, thanks very much.
Good. Cool
You're
stuff.
welcome. You might have, sometimes Spice has some versions of Spice support a switch, so you can then just toggle it directly on your schematic, so you don't have to wire and unwire it.
Yeah, I couldn't find that switch when I was looking for it. It looks like it's SW, but I put a switch in and it said it didn't recognize that switch, so I just put a line in instead.
Okay, good. So what do we got here? 9:15. Go ahead, Cherry.
Not a related question, but does anybody know whether there is a Hamfest coming up somewhere in the near future?
I was reading somewhere. I can't remember where it was. Is this Al there? Got the
And seeing everything is cancelled.
well, so yeah, I think there was. I was reading somewhere, and I think it might have been the Rack magazine that there was 2 Hamfests coming up, but it didn't say whether it was canceled or not. I'm assuming it will be.
Yeah, because their site for the upcoming events, the Rack website for the upcoming events, everything is cancelled.
Okay. So, anything else, guys? I guess that's it. Okay,
Time to watch some
gentlemen.
basketball.
What's that?
Time to watch some basketball.
Yeah, let's go. Let's go. Okay, guys, thanks for joining in tonight. And our next Wednesday session is next month. Have a good evening. Have a good day tomorrow.
Thanks very much.
Okay, bye-bye, guys.
Thanks, guys.
Good night. See everybody next time.
Oh, no.
Okay, I can't get out of this.